Morning to everyone present over here. My name is Devashish Patro and today I will teach about the concept Markov model in AI. The Markov model is one of the statistical model in AI and the main purpose of the Markov model is to find out how these systems transition from one state to another. Okay, first is what is the meaning of the Markov model? Markov model is one of the statistical models, and the statistical model means it is basically used in AI. And why it is called the statistical models? Because it is totally linked with the probability. And there are two types of Markov models. First one is DTMC, and second one is HMM. The full form of DTMC is discrete time Markov chain, and second one is HMM, hidden Markov model. So basically there are two types of Markov models, DTMC and HMM. The main purpose of the Markov model is that to check how the system transitions from one state to another, and it basically follows the concept motionless property. Motionless property. It means that the Markov model will predict the systems on the basis of, for example, this is the AI system, and the Markov model will predict this AI systems on the basis of the present state. It will predict only on the present state, not on the past sequence states. It means that if this is the AI model and this is one of the robot which is situated at XY, and the Markov model will basically find out the prediction of the next state of this robot, not how far the robot has came from another state to this state. It will only find out the prediction of the next state from here. That is the one of the property of Markov model. That is the motionless property. Okay. So we will go to the next part. That is DTMC. So what is the main definition of DTMC? DTMC stands for discrete time Markov chain. It means here states are visible. States are visible. It means, for example, I will show one thing, and in DTMC it follows this probability matrix. For example, today, tomorrow, sunny, rainy. Okay. So here easily you can see the states. States means here the transition is happening. For example, if today is sunny, then the probability that tomorrow will be sunny is 40%. And if today is sunny, the probability that tomorrow it will be raining is 70%. So here states are easily visible. That's why it follows the property and principles of DTMC, discrete time Markov chain. So here easily you can see the states. Here the transition is happening from rainy to sunny. So the probability of changing the weather from rainy to sunny is 60%, and the probability of the rainy to rainy is 20%. So here DTMC is very important in this scenario, because here easily you can see the states. And now we will go to the next part, that is HMM. HMM stands for hidden Markov model. Here the states are hidden. Here the states are hidden. Only we can see the visible outputs. It means that whenever I am speaking in front of this camera, then anyone cannot identify how I am. It means the camera cannot identify, or any person cannot identify that I am happy or sad. Okay, so here the HMM will find out the hidden states. The states are hidden. For example, if I am speaking, I am coming to school. So here phoneme, PHONEM, phoneme. Phoneme means what? Phoneme means it is the smallest individual unit of English language. For example, cat, CAT, cat. So here there are three types of phonemes. Sorry, there are three phonemes. CAT. It means K is represented as, first C is represented as K. So this is basically, it is sound. So wherever I am speaking cat, so here C means K is phoneme, and this phoneme is hidden. And A means this A. This represents A. And T means this T. So there are three phonemes in this K. So the Markov model will find out the how much hidden states are there. There are three hidden states are there. K. Whenever I am speaking K, you can only hear the K, but you cannot able to understand. Sorry, you cannot be able to observe the phonics. First phoneme, second phoneme, third phoneme. You cannot able to observe. Only the HMM, hidden Markov model, can identify how many phonemes are there, and it will uses what? Various kinds of properties, and it usually has the emission probability. Second is transition probability. Of course, the HMM stands for hidden Markov model. It means the states will be hidden states. Fourth one is observed symbols. Observed symbols means what? Observed symbol means whenever you are trying to speak cat, you are only observing the word cat, but you cannot be able to observe the phoneme C, A, T. These are the phonemes. You cannot be able to observe these phonemes. Only the HMM can understand. Transition probability. So the emission probability, transition probability, hidden states, observed symbols. These are some of the properties which HMM follows. Now we go to some of the features of Markov model. First is motionless probability. Second one is sequential plus stochastic. Third one is it uses the probability matrix. So these are some of the properties of the Markov model. First is motionless probability. Motionless probability means the Markov model only predicts the future states on the basis of the current states. Okay, so it will basically ignore the sequence of the past states. Second is sequential and stochastic. It means that Markov model basically into what basically it configures the sequential plus stochastic. Stochastic means the situation which are uncertain. Uncertain. It means the weather, or you can say stock market. Stock market. You cannot be able to predict the stock market. So it is one of the stochastic environment. And third one it uses the probability matrix. Probability matrix means these kinds of a matrix having consisting of rows and columns. And it is basically used in DTNC because here the states are completely visible. Thank you so much, and tomorrow I will teach another topic in AI. Thank you so much. Thank you.